Good morning everyone and welcome to my YouTube channel. So for today we are looking at questions involving sets, simplifying sets using the associative and distributive laws. So now what are some of the things that you need to know? So some of the things that you need to know are if you have A intersection with A complement, now A complement and A are different sets, meaning to say they have nothing in common, meaning to say this one will produce what we call an empty set. Now if we have A union of A complement, when we combine what is in A and what is not in A, we will always have the universal set like that. Then if we have an empty set complement, this results into what we call a universal. So if you have an empty set but the empty set complement, it will always give you the universal. So from this we can start answering questions. So the first question is, if we have been provided with A is equal to, we have A intersection of B close, we have the union of A intersection of B complement. So now, provided with such a question, we have been told that we are supposed to show that the sides are equal. So with these types of problems, you pick the complex side. So we are going to pick the right hand side. So from the right hand side, we are going to have, we have A intersection of B close, we have the union of A intersection of B complement like that. So from here we are going to use what we call the associative law. So what you can just think of the associative law, it's as if you are factorizing. So you will realize to say A is common here, it is also common there. So you are going to pick A. It's more like you're factorizing. Intersection is common here, it's also common there. So we have the intersection as common. Now the only thing that is remaining is B is not common. Then the union is not also common. So we have B union of B complement like that. Now from the rules we have established to say A union of A complement is a universal. So we are just going to have A intersection with the universal. So meaning to say A intersection of with the universal is equal to, we have A intersection with the universal is equal to A itself, because that's the only thing that it will have in common. So that is how we use the distributive law to answer that question. Let's also try another problem. So let's try another problem. So the second problem is saying that, let's say we have open brackets, we have A intersection of B close complement, we have the intersection of A complement union of B, then we have complement. We have been taught that this should be equal to A. So let's try to show it. So from the first thing, we are going to pick the left hand side, which is this side. Now from De Morgan's rule, we have established to say when we have a complement outside, it can affect all of this. So this will be the same as A complement. Now what happens to this operation? It will change. If it's intersection, it will change to union. So we have union of B complement like that. We close. Then we have the intersection of A complement union of B. This outside intersection can affect everything, but we are going to show it at the later end. So now here we are going to now use the associative rule, which is more like you're factorizing. So we have something like A complement is common, so we have A complement is common. What else is common? Even the union is here, it's here. So we have the union of the union. Now B complement is not common, so we are going to have B complement. Even the intersection will be here and be like that. Then we have outside complement like that. So now if I multiply this A with throughout here, I can go back to this. So now when I reach this stage, A complement union. Now if you have seen if you have A intersection with A complement, it's equal to an empty set. Even here, B complement intersection B, the only thing in common will be an empty set. Since A B complement and B do not have anything in common, so the set will be an empty set like that. Then we have the complement outside. So from here we are going to establish that we have A complement, because A complement union, if you combine with an empty set, it's more like you're not combining with anything, so it will just be an A complement complement there. So we have A complement complement. A complement complement will give you, from the rules that we have established, A complement complement is equal to A. So we can say hence shown. Thank you very much for watching my video. I hope you subscribe and like for more.